Good day to you. You are welcome to Brilliant Surya College class. And the topic that we'll be considering for today is elementary differential equation. And under elementary differential equation, we have the definition of a differential equation. Any equation that contains a derivative is called a differential equation. And we also have types of differential equation. We have partial differential equation and we have ordinary differential equation. Then other ordinary differential equation. An equation is said to be an ordinary differential equation when it involves only one independent variable. And again, an equation is said to be a partial differential equation when it involves more than one independent variable. Then we also have the order and the degree of a differential equation. So as for the degree of the differential equation, to obtain the order of a differential equation, the highest derivative, that's the order. So the highest derivative of the differential equation is the order. And to obtain the degree, wherever we obtain the order, that is where we will get the degree. Because this question says, classify each of the following equations as to ordinary differential equation, that's ODE, partial differential equation, that's PDE, then order and degree. And the first one I will have here is dy dx plus xy equals to cos x. So now, from our previous video, so we actually explained the definition, we actually emphasize more on ordinary differential equation and partial differential equation. So this one involves only one independent variable. The one that we have here is the dependent variable, while this one is the independent variable. So this is an ordinary differential equation. Ordinary differential equation. Then the next thing is to classify it as to order. That's order 1. So the order is order 1. Then the degree is 1. Order 1, degree 1. Because what we have here is we obtain the degree and the order from it. This is the order. Order 1, degree 1. And this is the order. So this is the order. Then to obtain the degree, the power, which is 1. So the highest derivative that we have here is just 1. We only have one derivative, which is dy dx. So that's an ordinary differential equation with this letter D that we have here. That's to tell us that this is an ordinary differential equation because, and again, we have one independent variable. Now going to the second question. Here again, this is an ordinary differential equation because here we have this letter D, normal letter D, that is for ordinary differential equation. Again, we have only one independent variable, which is what, letter T. Here we have T, that's the independent variable. And the dependent variable here is Q. Q is the dependent variable. So now this is an ordinary differential equation. And to obtain the order, we'll go to this particular place. The highest derivative that we have here is partial, and that's the square Q over the T square. The square Q over the T square, that's the highest derivative. So, and it is of order 2. So that's order 2. And to obtain the degree, we'll come to the particular place where we actually obtain the order. That is where we'll get the degree. And the power of this one is what? That's just power of 1. So that's degree 1. So this one is degree 1. So we have order 2, degree 1. This is an ordinary differential equation. And the next one is, the highest derivative that we have here is 3. That means we have order 3. That's y prime prime prime. So this is an ordinary differential equation. When you see this prime prime prime, it is still under ordinary differential equation because this y prime 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 can also be written as, that's this cube y over the s cube. This one can be written as the cube y over the s cube. That is the cube y over the s cube. So that's y prime prime prime. So that's the cube y over the s cube. So now here we have this an ordinary differential equation, and this is of the third order, and the degree here is 1. That's degree 1. And going to the next question, the highest derivative that we have here is this one, partial square z over partial s square, and this one too. So is the second order differential. So we want to classify this one, maybe it is ordinary or partial differential equation. This is a partial differential equation because here this one involves more than one independent variable. Here we have x and y at the down part. So here we have x and here we have y. So this is a partial differential equation. Then as for the order, it is of order 2. We can obtain the order from anywhere. So the order is 2 because all of them, they are of second order. This one is second order. That the highest derivative here is 2. All of them are the same thing. So that's order 2. Then we can obtain the degree. So the degree is 1. So the degree is 1. And the next question I have here is, we have y prime 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 raised to power 2 plus xy 2y. then y prime raised power of 2 plus xy. So now what we have here, this is an ordinary differential equation, and it is of order, the highest derivative that we have is this one, that's order 3, and the power, that's the degree, that's degree 2. So we have degree 2. So here we have order 3, degree 2, ordinary differential equation. And the next question I will have here is zx raised to power 6 plus zx minus xy. So I make this one zy, sorry. Zx raised to power 6 plus zy minus xy. So this is under partial differential equation, because this zx can also be written as partial z over partial x. So zx is the same thing as this one, partial z over partial x. So now this is under partial differential equation. Then the other there, the highest derivative that we have here is order 1. Then the degree, we have degree 6. Degree 6. And this, they are of the same order. The first order and this is the first order. So they have the same order. Then we can pick the one that has the highest degree. We can consider the one that has the highest degree. Then we pick the other here, order 1, that's degree 6. And the next question I will have here, this one is under partial differential equation. When you see something like this, that's under partial differential equation. So this is under partial differential equation. And the other is order 3. The highest derivative that we have is 3, this one, 3. Then the degree, that's degree 1. So the degree of that one is 1, degree 1. So now we are going to this particular one again. The highest derivative that we have here is the square over the s square. And this is an example of ordinary differential equation. And again, the other here is 2, degree 2. That's order 2, then degree 2. So it's degree 2. Order 2, degree 2. So we can't come to this particular place because this one is just the first order. This one is having the first order, dy dx. Then this one is just the first derivative. So this is the highest derivative that we have, the square over the s square. So we obtain the order from here, and then also obtain the degree from here. It is where we obtain the order, that's the same place that we obtain the degree. So you can't obtain the order here and go to this particular place and say it is order 2, degree 3. It is not done like that. So it is order 2, degree 2. So now the next question that we have here is example 9. So now we want to get the order of this one and the degree. Maybe it is partial differential equation or ordinary differential equation. So this is an ordinary differential equation. That's the first one. So and the highest derivative that we have here is this y prime prime prime. That's order 3. So that's where we get